Yeah.
Also, in the perimeter comparison, or not perimeter two,
Yeah.
when you're using the F string, um, like you are doing x equals the x integer input f enter a coordinate for the point index and all of this,
Uh-huh.
then you don't repeat the the thing too much times. Why didn't you do it for the Len algorithm? You are computing by hand each time x1, x2, x3, x4, but you could also do a function with this, then it's faster.
Yeah. So the thing is, in introducing functions and writing your own functions, I didn't want you guys to think that anytime you have any repeated code at all, you must turn it into a function, you know? The idea is that like you don't have to. In situations where you know you're going to repeat something a fixed number of times and it's not too large, like say only reading 5 digits, like it's not the end of the world. And like each of those lines is like a single line, you know? It's not the end of the world not to have a function there. And in fact, it's probably a little clearer just to write out the actual lines themselves. But really, all I wanted to have, like the purpose of asking you to do that in the perimeter two question was just to have you practice writing a simple function. But that being said, I don't want you to think that like anytime I have repeated code, I have to write a function for it. That's not what writing functions is about. It's really about modularizing larger blocks of code that do one cohesive thing and that cohesive functionality appearing in multiple places in your code. That's what functions are all about. But it is a good question. Yeah. Anything else about the assignments, about anything? Yes, they have. Yeah. 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 Okay. Well, I guess let's just get started with the lectures then. Cool. All right. So today we're talking about loops. Um, and yeah, this will, as with most things in the course, it'll become clear what I'm talking about when we do examples. So maybe let's just dive right into the slides and cover the high level stuff first. Um, but yeah, I guess before I get into the details here, a loop lets you, like we saw conditionals last class, right? Which allowed you to define like, which basically allowed your code to make decisions. Yeah. So loops are another control flow mechanism, um, and where if statements and match statements let you branch in your logic, what loops allow you to do is to repeat a section of code that you've written multiple times based on some logical condition. So it's a different kind of control flow. Yeah. Yeah. Question.
As lecture, was the match statement really important, or like in Code 2 we will like mostly use if and else statement?
So in like 90, like most of the programming that you're going to see, you're going to use if statements, but you should know what match statements are. There's some situations where it's a lot cleaner and more convenient and readable to have a match case statement instead of an if statement, basically. And you would use them in the situation that I mentioned last lecture where you're testing. If you ever find yourself writing an if statement that looks like if variable is equal to value one, else if variable is equal to value two. Also, like in this situation, a match case is a better option for you. Yeah. Uh, okay. So yeah, right. While loops. Okay, let's see what this is doing. So here's just an example of some while loop syntax. So you'll notice it kind of looks like the if statement that we saw, right? Like there's some Boolean condition and we delineate what's in the body of the while loop using indentation again. Um, except instead of like where it kind of differentiates from an if statement is that so long as that Boolean condition is true, then we're going to start executing, right? And we're going to execute whatever code is here. And when we reach the bottom of this indented code, then our program will jump back to the first line and then do that again, and then jump back to the first line and keep doing that so long as this condition here evaluates to true. Okay? Uh, let's see an example of this. I think that's the clearest thing to do. Okay, so let's make a new file and call it manyhello.py. No, don't do that. I want it to be manyhello.py. So if you remember way back when, ages ago, to the first lecture of this course, like a week ago, one of the first things that we did was, oh, what did I do? Uh, Control R. No. Ah, that's not what I wanted. Okay. Delete G. There we go. One of the first things that we did was we had this program that just printed and said hi to the user, right? Hey, buddy. And we could do this multiple times, right? If we just kind of and then paste, paste, paste. Like we can, and then run this, and you'll see it prints 3 times, right? But what if we want to print 5 times, or 10 times, or 1,000 times? It would be really inconvenient to have to manually type a print statement 1,000 times, right? So let's see how we can replicate this exact behavior with a while loop. So we'll get rid of this, and then this. What we're going to do now is, actually, I'll just do it from the top. We're going to have a while loop that says, well, first, our condition is going to be based on a counter. So we'll set some counter equal to 0. And then we'll have while counter. We want to print 3 times. So I'm going to say less than 3. Okay, thank you. We will print our greeting string. And then what we'll do is we'll update, whoops, our counter variable equals counter plus 1. Now, if we run this, you'll see that it's done exactly the same thing that we did before. It printed 3 times. And the way that it was working was, so long as this Boolean condition is true, it's going to keep printing. So what this loop does is, it enters the first iteration, counter is equal to 0. This passes the loop check. So we print, and then we add 1 to counter. Now counter is 1. 1 is still less than 3, so it passes the loop check. We print again. Next time around, counter is equal to, 2. Still passes the loop check. We print again. But once this hits 3, 3 is no longer less than 3, and so we exit the loop and we're done, right? And if we want to change the number of times we print here, all I have to do is change what the upper limit is in my loop condition. So maybe I want to print 5 times instead. And I run this. Whoa. Why is it only... Well, it's kind of hard to see because, hold on, maybe if I like make this... There we go. But it's printing 5 times now, right? And maybe we want like a variable number of iterations of this loop. That's another thing we could do, right? So we can have another value, n, that controls how many times this loop runs now. And you can see we've changed our control flow of our program so that the loop depends on some variable that's actually in our program. This isn't something that we could do before with the tools that we had, right? Repeating code like this based on the value of some variable. Any questions about this? Like loops, while loops? Are we good on like the basic mechanics of what's kind of going on here? Okay, if there are no questions about the while loop, then I'll use this as the occasion to introduce another little syntactic sugar, so to speak, of Python. If you remember back when in the first lecture, we saw an example of a bunch of different operators, right? And one of the categories of these operators was assignment operators. And this included things like the equal sign. But there were other assignment operators in that category. And I want to show you an example of another one. We're going to look at the plus equals assignment operator. So I'm going to comment this out here. An equivalent way of writing this line that we just wrote is you could write counter plus equals 1. Whoa, what does that mean, right? So this is just a shorthand. This assignment operator expands into this, basically, right? It's just a way of saying add one, add the value on the right side to the value on the left side, right? So these two statements are equivalent. And once you've understood how this plus equals assignment operator works, the way that the other assignment operators work that look like it are very easy to figure out. You also have like minus equal that does this. You also have times equal, it just like takes, I mean, this is kind of a useless statement because it just multiplies the value of the thing by one. But yeah, these are just shorthands for using an assignment operator and then the corresponding arithmetic operator that's to the left here. Okay? Just another operator to expose you guys to. Okay. So what else did I want to say? Okay, yeah. I guess we can move on now to. So we saw while loops. What we're going to see next are some special statements that assist us in changing the control flow within a while loop. And the first example of this keyword, of a special control flow keyword that we're going to see, is the break keyword. So what the break keyword does, all it does is anytime you hit it in a loop, it exits the loop. Okay? So the general syntax for this sort of thing is usually you have it enclosed in some kind of conditional, right? And once that exit condition is met, then that if statement, like the body of that if statement over here, will execute. And the moment we see break, we just exit this loop. Okay, it's like a different way of handling control flow, right? And the break condition is really useful for doing things like validating user input. So let's see an example of what I mean by that. Let's write a new file. And call it division validation. Clear this is kind of a mess. So what we're going to want to do in this program is write some code that prompts the user for a numerator and a denominator, and then just divides the number and prints the output, right? So I mean, this is like very easy, hopefully kind of easy for us to do with the tools that we've kind of already seen at this point. We could just have we could have a variable that we call numerator, and we'll accept that by casting float input. We'll prompt the user for enter the numerator. Okay. If I can spell. All right. And then the denominator will accept the same way. Input, enter the denominator. And then what we'll do is we'll just, have the quotient or print the quotient. We'll say print. The quotient is, and then we can use a fancy schmancy f string here. Numerator divided by denominator. I have to actually enter the f symbol for that over here. Okay, so what this does, enter a numerator, I don't know, favorite numerator 6, and then 2. Wow, crazy, crazy stuff, right? We've written a program that can divide. What is this, like a $400 laptop? We've made a $400 calculator that can't even do all the other operations that a regular calculator does. Bravo, bravo. Course over, guys. No, what I actually want to do with this example is show an annoying corner case that you may remember from basic high school math, which is what happens if the denominator that I want to divide by is 0? Yeah, question. You want?
It was you question the class like what does happen if the denominator is 0?
Oh yeah, sure. Okay.
Then it doesn't work.
It doesn't work. Exactly. Yeah.
Then we gotta use break. Maybe.
Yes, yes. We're gonna use break to solve this. Let's see how. Sorry, what was your name?
Ryan.
Ryan. As Ryan pointed out, when we divide by 0, Python doesn't like that. You can't divide by 0 in real life. Python isn't magical. It's not gonna do that for you, right? So you get this 0 division error. And it would be nice if there was some way that we could keep annoying the user to enter a valid denominator, a number that isn't zero. So let's see how we can do that with a while loop now. So what we'll do is we'll say we can wrap this denominator statement in a loop that looks like this. We're going to say while true, we're going to get the denominator. And if the denominator is equal to 0 or is not equal to 0, then we'll break out of the loop with the break statement. Otherwise, we'll just keep annoying the user to enter a valid denominator. Okay? All right, so let's see what this does now. Run. Okay, enter the numerator, 6. Enter a valid denominator. Maybe I want my computer to explode. I press 0. Ah, it's asking me again. No, I really want it to be 0. I said I really want it to. Okay, anyway, the point is that you could do this as many times as you want. The way that this loop works is, remember, we said that we ran this loop so long as the condition after the while keyword was true. And here I'm just saying true. So this loop will run until like the heat death of the universe if I don't break out of this condition, right? This loop is always, always, always going to execute. And the way that I'm exiting it is with this break statement, right? Like when I finally enter something that's valid, like 2, then it's like, okay, fine, the quotient is 3, Yeah, question.
And then replace the if with the else or not?
Yes, yeah, you could. So this is like break statements are one way of handling control flow in your loop, but you could rewrite this loop in exactly the way that you're suggesting. So let's see how we would do that. So it's convenient to write this way because we can prompt the denominator, like we can prompt the user within the loop. And if it works the first time, then we don't have to write anything else, right? But maybe another way we could do this is we could take this, put it out here, right? And then, while the denominator, but it's a good question, if I can spell, denominator is not equal to 0, then you just keep prompting the user. Visual mode, can I copy this? Maybe I could just paste. And then you don't need this break statement. So this code is identical to what we wrote before, right? And you can test that yourself by running it. Saying enter the numerator 6, the denominator 0. Wait, what am I doing? What am I not doing here? Float input, enter valid denominator is not equal to 0. Oh, it's equal. Yeah, thank you. That's what it is. So you got to flip the logic a little bit. But yeah, thank you for pointing that out. Because we want to keep looping so long as it's 0. So if we do this now, 6, 0, 0, 0, please, 2, and then it prints and exits. So yeah, this loop is identical to the loop that we wrote before. Yeah, break statements are a different, often very convenient way of modifying control flow in your while loop. Okay. All right, now let's see a bigger example that kind of ties all of this together. So if you remember, one of the examples that we saw last lecture was we programmed a simple version of craps. And it wasn't the full version of craps. It was just this simplified version where you only play and roll once, right? If you get a 7 or 11, you win. Anything else, you lose. That was kind of the way that we did it. But now that we have unlocked the power of while loops, it is within our grasp to actually write the full version of craps. And the full version of craps, I guess we'll make a new file for this. And we'll call it full craps. Bit of a funny name for the file. I'm just going to write what the rules are for, in case you're not familiar. So the way that craps works is it's similar to the first step that we had before, where you're going to roll once. And if you get a 7 or an 11, you win. But if you get a 2, a 3, or a 12, then you lose right away. And if you get anything else, if you roll any other number, that roll becomes what's called the point. And then you have to keep rolling until you either get the point again, in which case you win, or you roll a 7, in which case you lose. Okay? So perhaps in my description of the way craps works, you can already see where a loop would be useful to encode the logic of this code, right? So, okay, is everyone clear on the rules of craps? Any questions about that? I bet you didn't think you were going to learn how to gamble in your Foundations of Programming course, but hey, here we are. Okay, yeah, cool. Then let's see how we can actually write this. So, one thing that we're going to need when we do this is to make our gambling interesting, we want to have chance, right? And does anyone remember how we got access to randomness? Yes, Ryan.
Random.
Yes, import random. So we're going to use a Python library, module called random, that gives us access to a bunch of useful functions for getting pseudorandom numbers. And let's start the way that we did before. So, we're going to have an input statement just to kind of like start up the game that says, welcome to craps. Welcome to the craps table. Craps table. Press enter to roll. Okay. And then the user is going to hit enter to roll. We don't care about the output. We're just doing this so that, it like helps with the pacing of our game a little bit if they have to press enter first. And then what am I going to write next? I want to get a dice roll. How am I going to do this? It's kind of what we saw last time. Maybe somebody else wants to suggest what the next line of code should be. Yeah.
You can set a variable like dice one and random.
Yeah, sure. Okay, so let's make a variable die1. And what am I going to set it to? Yeah. Randint is the name of the function. And it's in the Python module. So how am I going to reference it in a way so that the interpreter knows what I'm talking about? Yeah, exactly. Great stuff. Random.randint. And what am I going to pass as the arguments to this function? What else? Yes.
1 and 6.
Oh, yeah. There we go. You both had the same thing. It was like weird down the line of sight. But okay. Yeah, 1 and 6. This is just going to tell me, give me a random integer within this range. And then, I'm going to want to do this second time. So we'll do die2. It's just the same thing. And now I'm going to store the result in this thing called a point, right? So we'll do die1 plus die2. And now I have to do some conditioning. Does anyone want to suggest what conditional I should write to encode the logic of the game that I just described a couple seconds ago? We're going to need, yeah? You have a suggestion? I can see it in your eyes. That's okay. So the rules are 7 or 11 on the point, you win, and 2, 3, or 12, you lose. Yeah.
Move this while die1 is not 2, 3, and 12. You continue the roll.
Yeah, yeah.
Die2 and then at the end you have the if point is use this or that, you win, else you lose.
Yeah. So I am going to want a loop, right? But there's like these kind of two phases of craps, right? So in the beginning, this part is this is to set the point. Anything else becomes the point. And in phase 2, right, we're just going to keep rolling until you get the point. in which case you win, or you get a 7, in which case you lose. So this is kind of like you're getting to the right place. I'm going to want to loop for this second phase. But before I get there, I need to figure out whether or not I've won or lost just on the point roll, right? So to do this, we're just going to start with a good old-fashioned if statement. We'll do if the point is equal to 7 or the point is equal to 11, then we win, right? You could just print, you win. Woo. Okay. What am I going to write next? Yeah. Yes. Yeah, exactly. I'm going to use the elif statement to handle the next case. What's the conditional for that going to be? Yep. So I'm just going to check that it's one of those. So we'll do point is equal to, whoa, point is equal to 2, or point is equal to 3, or the point is equal to 12. Then you lose. Ah, darn. Okay. And then this is the catch-all case. Yeah. Yes, exactly. So we're going to do else. We're in the second phase now, right? Now we're just going to keep rolling until we win because we have a problem and we can't leave the table until we get that high. So what I'll do now is I'll put an else, and what we're going to say is while something, right? We know that we need this much, but what should my while condition be? I need to roll again, right? So I need to do this thing again. And I could copy and paste this right back here and set it equal to roll. But this is the kind of thing that maybe it would be convenient to have a function for, you know? So let's take this and make a function that we'll call roll dice. And it's not going to accept any arguments. It's just going to do this thing, oops, for us. Visual. It's just going to encode this dice rolling logic for us and then return what the roll is. Okay? Call this roll instead. And so now here, in order to get my point, I just need to say point equals roll dice. Right? And here, in order to get my first roll of like the second phase, I could just say roll is equal to roll dice. And now my while condition, how am I going to do this? There's a couple ways you could do it. We could do it with a break statement. We could do it with the condition to exit right in the while loop. Any suggestions on which way we want to go? Let's try it with a break statement. So do while true. What we're going to do is print you rolled a, and then give them what the roll is. Insert F here. And if the roll, this is the game logic part. So if the roll was the point that we had earlier, then you win, right? Print. You win. And what do I have to put after this? Yes, break, exactly. Then we break. We're done. We did it. Okay. Otherwise, what do I need to check for? Yeah. If it's a 7, yeah. So otherwise, if it's a, like maybe I'm going a little too slow for you guys. If the roll is equal to a 7, then 7, then we print, ah, you lost. Okay, and we'll break out of the loop in this case too. Done with the game. And in any other case, right, no matter what I roll, I just want to keep playing. We'll just keep doing this loop. We'll keep rolling. Oh, but the only thing is, does anybody see anything wrong with what I've written so far? Any mistake? And yeah?
Are you repeating the game twice in your code?
Oh, no. So the game kind of happens in 2 phases, right? There's like the first roll to establish the point, and then we keep rolling until we get the point or the 7, assuming that we didn't win or lose on the first roll, right? But there is a subtle mistake in the code that I've written so far. Yeah? Oh, yeah. So the question is, why don't I use an if statement here instead of an elif statement? And you could use an if statement here. But this goes back to something I mentioned last lecture. Oh, sorry. Actually, let me just check the time because we do have to leave a little bit for the exam at the end. But it goes back to something that I mentioned last lecture, which was when I want to use elif statements is if I'm checking something, if I'm checking 2 conditions that are dependent on each other, such that if the second condition doesn't happen, or if the second condition happens, it means the first condition didn't happen, right? So I can either roll the point or the 7 here, right? I'm not going to roll both of those things. So I'm only ever going to evaluate one of these conditions, right? If I used an if statement here and I didn't, and like, let's say I used an if statement here and I rolled a 7. Or let's actually, if I used an if statement here and I rolled a, what's it called? A point, then in this particular case, because I'm breaking, I actually wouldn't run the second thing twice. That's the key thing. But the general design pattern is such that if I weren't breaking here and I were continuing, then, and I rolled a point, then I would just be unnecessarily checking a thing that I know to be false. You know what I mean? And so in general, when you're checking conditions that depend on the same variable and you only know one of them can be true, you want to use elif statements instead of if statements. It just saves you from doing unnecessary checking. But you are right in this particular case in that because we're breaking, I could actually just do an if statement here and I would never unnecessarily check. Does that make sense to everyone? Yeah? But it's just a good habit. Like I write it this way because I'm just used to writing elif statements this way. But yeah, it is a good observation. Yes. Yeah, for sure. Here, I can actually shrink. This is way bigger than it needs to be right now. You wanted to see this? Yeah, you actually have to call it to get the point established. Yeah. Okay. So back to the question that I asked at the beginning, there is a subtle issue in the code that I've written so far. I'm curious if anyone can see what it is in the setup that I have here. So what we're doing with this loop is we want to, yeah, there was a hand briefly, a flicker of hope.
You're rolling how many ones? The rows.
Yes, exactly. The roll isn't in the loop. So it's just always going to print the same roll over and over and over again if I didn't get a 7 or a point until the end of time, right? I'm never actually changing the condition that lets me break out of the loop in my loop. So the fix to this is I need to take this and put it in my loop. Right there. Okay, so now I'm rolling in the loop and I'm just continuously rolling. And if I'm getting either of these conditions, then I'm leaving the loop. But that should be it. I think we've covered everything that there is to cover. So let's see if it actually works now. Okay, we'll save it and make this a little bigger here. Run it. Press enter to roll. Okay, cool. Oh, well, that's kind of lame. It doesn't show me what I rolled. Okay, let's change it so that it actually prints what the first point is. So print first roll is, how did I do this before? I guess, yeah, let's just have it print what the roll is here. Okay. And go down here. And then it'll tell us if we won or we lost. And in this case, maybe in this else case, what we'll just want to do to add a little bit of clarity is we'll say what the point is. Print the point is point. Okay. So then we'll go here. Okay, now let's try this. Okay, welcome to the craps table. Oh, dang, we crapped out right at the beginning. That is the technical gambling term for this, by the way. If you roll a 3, a 2, or a 12 at the beginning, you say you crapped out. I'm not just making that up. Okay, let's try something a little more interesting. Maybe we can get to the loop. Oh, wow, we're really unlucky. We got a 3. Dang, okay, we crapped out again. It's not my day. Okay, come on, big money. Whoa, okay. It did a bunch of stuff. To maybe slow down the execution of this program, it might also be nice to prompt the user to enter to roll again before we do this again. So let's, just to kind of slow down the execution of things, press enter to roll. Then they can roll. Okay. Now, all right, enter to roll. The first roll is a 9, so our point is set to a 9. Okay, press enter to roll again. We rolled a 4. It's not the point, and it's not a 9, so we're still going. We're still in the game. Enter again. Ah, we got a 7 and we lost. Okay. So, any questions about this stuff that we? Yeah.
I'm a bit confused about the while true, like,
Mm-hmm.
um,
Yeah. What's going on here, right?
yeah, like what does it mean? Like, what condition are they choosing?
So the way that the while syntax works is you write the keyword while and then some Boolean expression. And so long as that Boolean expression evaluates to true, it keeps running the loop. But here I'm just hard coding true as my condition, which means it always evaluates to true. And so the loop is always going to run. It's just a way of writing an infinite loop, basically.
The loop you run until like in our if statement that you something that
Until we get to a break statement, right? But if you're going to write a while true condition, you better have a break somewhere in that loop. Otherwise, it'll just keep going. Yeah. Any other questions? Yes.
Like, okay. Function. Like,
Why did we use a function?
like, why was it useful? Like, very useful. Like, why didn't we just continue as we were going with point for day 1 to day 2?
Oh, because I need to roll a second time, right? Like I need to re-roll when I get to this second phase of the game where I keep rolling to get either the 7 or the point, right? And because I'm doing this rolling behavior more than once, and it's like a very simple fixed set of lines that I'm always doing it, it was just like a useful place to write a function, you know? You don't have to do this again, right? You never have to write a function. It's just kind of an art form. It's a matter of taste to know when you should and when you shouldn't write a function. And this is a situation in which, yeah.
And why did we like change? In the beginning, we were using each point for 7, but after like we replaced point by row. Was it because of the scope of point, which is like a big variable?
No, this is just because of the rules of craps,
Okay.
right? Like the win condition becomes when I score a point, when I roll a point in the second phase of the game. So rolling a 7 in the second phase of the game means I lose, but rolling a 7 during the first roll means I win. Now, this is just the rules of the game, kind of. Yeah. Any other questions about our craps game? Okay. Cool. What else did I want to talk about? Okay. covered that. Yeah, so I guess there's maybe one final thing I want to talk about is just kind of a convention for writing neat and portable code. We haven't been doing this so far, but it's a practice that I want to start encouraging you guys to get into. I didn't want to do it right at the beginning because I didn't want to confuse you with unnecessary stuff. But it's a good habit when you're writing, like you can see, we're starting to write Python code that's like, it's getting pretty complex. Like this is 39 lines of code. This is the longest thing we've ever written so far, right? Unless maybe your Lin algorithm code was longer. Um, but it's a good habit when you write this sort of thing to have a main function that captures the main behavior or logic of your code, and then to just call that main function at the very end of your Python script. So let's see how we would do that here. So after my definition of roll dice, everything below line 9 here is kind of the main behavior of my code, right? It's the thing that I want to run directly. So what I'll do is I'll define a function called main, and main will just do everything that I just wrote, okay? So you got to indent, do control mode, shift, whoa. Tab that. So main just kind of captures all the salient behavior of my main program. And to actually get this function to run, because Python doesn't run function definitions, I'm just going to call main at the end here. Okay. This is just a neat way to kind of package your code together. One habit that I want you guys to kind of get into. All right. Now, the other cool thing about loops is, remember how last lecture we saw that you could nest if statements? You can also nest loops. You can have loops that run inside of other loops. And you can even have loops within those loops. You can have as many loops as you want, in fact. It gets quite convoluted quite quickly. But to illustrate an example of this, you know, our craps game is fun and all, but we wouldn't be very good gamblers if we could only gamble once. So maybe what we want to implement some functionality that prompts the user if they would like to play again, and then repeats everything that we've written so far, right? So they can play multiple craps games or rounds of craps and lose all of their money. Let's see how we would do that. So we're going to use a while loop again, right? And the question kind of, yeah, in the back. Oh, yeah. Please. Yeah, so it's because not all functions need to return something. And this is an example of a function that I don't, you know, it doesn't really return anything. It just kind of executes some functionality, which is simulating our craps game, right? Yeah, good question. Okay. Any other questions about stuff so far before we see how to nest this? Yeah. How did I? Oh, like how did I like select and then indent? Oh, yeah. So that's I use uh, I use this editor called Vim that has a bunch of like convenient text shortcuts for that you might come up in programming, like being able to select multiple lines at once and tab them all at the same time. If you're interested in learning how to do that so that you can write code a little more easily, I would recommend that you look it up. It's called Vim. I'll write it down. There's the chalk here. So Vim is a text editor. It's one of like a little bit of history. So it's one of like the two old school systems text editors that programmers used way back in the day, right? The other one was Emacs. And they're these like, literally, they're like two gangs of programmers, okay? All the Vim people think the Emacs people and Emacs sucks. And all the Emacs people think that Vim sucks. And I'm repping, you know, Team Vim over here. And I'm going to convert all of you as a consequence. But yeah, if you're interested in learning more, it's called Vim. It's spelled like this, Vim. And it's an editor, but there's an extension in VS Code that lets you use the same shortcuts. Yeah. Yes. Or you can do that, I guess. Yeah, I don't have a Mac, so. Yeah. Cool. Any other questions? Yes.
Could we put the roll dice function in the main function?
Could we put the roll dice function in the main function? Yeah, you can define functions in other functions. But the thing is that that function definition becomes restricted to the scope of that function. We'll talk about variable scopes and namespaces in a later lecture. I'm using the word scope because you used it, and I'm assuming that you know what it is that I'm talking about when I say this. But yeah, you could do that. It's just like maybe, for maximum portability, maybe I want to write some other functions that also have access to this, in which case it's like better to have my roll dice function outside of the main function. Yeah. Okay. So, okay, before we run out of time, let's see how we could nest this loop. So what we'll do is we'll put our while loop, because we kind of want to repeat everything we've written so far, we'll put our while loop at the very top of our program. So we'll have while, again, we could do like, I don't know, while true again, if we want to illustrate break statements, and maybe we can change it later. Just do all of this stuff. So Control V, Shift, do. So while true, just do this over and over and over again. But at some point, we're not a cruel casino. We would like to give them the option to leave, even though we don't encourage it. So what we're going to want to do is prompt the user if they want to continue playing, right? So after we've broken out of this loop in phase 2 here, where should I put, like, at what level of indentation? Because you can see we've gotten pretty in the weeds here, right? We have while loop, and then if statements in that while loop, and then while loops in the else statement. So our indentation is getting pretty complicated, and then we have ifs in that. So at what level here should I put my while loop that prompts the user if they want to keep playing? Yeah.
Bars at the third bar, like here's the first bar.
This one?
The second bar, and we should put the intention with the third bar.
This one right here that I have my cursor hovering over. Yeah, good. That's where we want to put it, right? Because we've broken out of the logic of our second loop. So we're going to want to have something like input. Do you want to keep playing? And then, I guess you want to be fancy about it. How should we do this? For simplicity, let's say, okay, press no, or I guess enter N to exit, and anything else to continue. Okay, and you'll notice that like I've kind of put these quotations or like this string across multiple lines. This is just a Python syntactic shorthand to write strings that span multiple lines. Like if you enclose them in parentheses, as is automatically the case in this function definition here, then Python will stitch them together for you. It's just so that you don't have really one awkward line that extends like way out here, basically, for legibility. So, and we're actually going to want to store the input value here so we can, I guess, have it play again. Input. And does anyone have a, yeah?
Look, we have to close the quotes if you want to write multiple lines, or.
Yeah, I think so, because otherwise you can have Python strings that span multiple lines using the triple quotation feature. But the problem with that is it will insert the new lines in the string. So if I want all this to be on a single line, then you want to do it this way, right? But good question. We'll see the triple quotation feature in a future example, so don't worry if you don't know what I'm talking about in a future lecture. Okay, so if play again input is N, then I break, right? Otherwise, it just falls through and we keep doing this entire loop. Yeah? We're kind of a cruel casino because if they make any mistake at all, we just have them keep playing. They got to enter N exactly. Now I don't know, we can test to see if this works. Okay. Welcome to the craps table. Press enter to roll. Whoa, I won. I got a 7 right away. Do I want to keep playing? Press N to exit and anything else to continue. Well, with a lucky first roll like that, don't mind if I do. Yes. And then it asks me, welcome to the craps table. Press enter to roll. Now I roll first, it establishes that the point is an 8. And we're in the inner loop now, right? I keep rolling until I get make this a little larger. Point again. Come on. Ah, the 7 giveth and the 7 taketh, right? It let me win the first time and I lost the second time because of it. So yeah, this is a pretty nice example of nested loops. One thing that I want to mention about nested loops is you'll notice that this break statement, it applies to the while loop in which it is written, the innermost while loop in which it is written. When I encounter this break statement, it doesn't exit the whole outer loop, right? It just exits this loop here and lets me keep running. When there's no inner loop here, but this break statement applies to the while loop in which it is written up here, right? Yeah. Any questions about this nested loop, what we just did? Pretty clear to everyone? Cool. Let's maybe as an example, we kind of saw how to convert. We have another while true condition here. We could rewrite this in a way that we don't use a break statement. One way to do that is if I get rid of this and I change my condition to while play again input is not equal to no, right? I'm writing an equivalent loop now. Then I keep doing this. But there's a problem with this. Does anyone see what it is? The way that I have it set up right now? Yeah?
You wouldn't hear it the first time. And not because playing input is at the very end of the big loop. Then the first time when we call the function, we wouldn't have value for playing input.
Exactly. In fact, this doesn't even exist. This would result in an error, right? So I need to define some initial temporary starting value for play again input that's going to let me enter the loop in first time and define the variable so that my condition knows what the heck I'm talking about. So let's start by saying play again input is equal to, hell yeah. And now this will work, right? I could run it again, but I think you guys get the idea. There's one final thing that I want to cover before we wrap up the lecture and go on to the exam. Yeah, question. Death. Oh yeah, like what am I doing with this thing? So this is just like, you don't have to do this, but the best practice is to define a main function that handles, you want to wrap all your code that you expect to run when you press this run button within this Python file inside a main function. And then put that main there, right? And then define functions that this main functionality calls outside that main function. This is just like a good way to structure your code. And if you look at I don't know if anybody saw in the assignment solutions, I wrote like 2 versions of the solution for the perimeter 2 and triangle comparison. One of them was the better option. And it was better because it was more modular and there was less repeated code. And that is actually an example of a situation in which this main function is really useful. So if you want to see when you should use that main function, I encourage you to check what the better solution directory and assignment one is. Yeah, to really like drive that point home. Okay. Cool. All right, well, if we're all clear on this, yeah, there was one final slide that I wanted to cover, and that was, go here. So we saw the break keyword, but I mentioned that there were a couple different keywords for controlling control or, doing control flow within a loop. Another one is can I go next? The continue keyword. And, the behavior of these keywords is kind of in the name, right? Whereas the break condition or the break keyword let us leave a loop entirely, If we ever want to write some while loop such that if we encounter some condition, we skip the rest of the execution of this iteration of the loop and go to the start of the next one, then that's what the continue keyword is for. So when I start my while loop, it's going to run all the code here. And if skip condition is true, it's going to skip or continue to the next iteration of the loop without running all the code that's over here. Okay, this is just another useful, convenient feature or keyword for you guys to be aware of. And the continue keyword is, it's useful for, get rid of that. It's useful for handling edge cases in your code. Like we saw a very simple example of division validation when I introduced the break keyword. But if we had like something more complicated, right? Like let's say you had some loop that checked if we were dividing by 0 and then did some like really complex math after that, then it's quite nice to be able to just have a continue statement at the top that lets you skip over all that instead of an if else with an else that has just this like everything else in your while loop, you know? It's just like a convenience for you. And as we brought up earlier, and as I'm pointing out in this note here, you can replace a continue and a break, like all of these things you can replace with if and else statements for your control flow. But a lot of the times it's cleaner and clearer to just use a break or a continue statement, as in corner case checking. Okay, these are tools at your disposal to write simpler, easier to read code. Yeah, okay, I think that was the end of the content that I kind of wanted to cover today.